Okay, so we'll first see some definitions, some important definitions. We'll see some important definition. First, we'll see some important definition, and then we'll go for some standard functions. So these definitions are also very important. Please note that. First definition, what we are going to get is about your polynomial function. Polynomial function. So what is a polynomial function? You should know it, right? Any function y equal to fx of the form, right? Fx would be like a polynomial. If I'll be getting any polynomial in x, yes, you go like this is a2x square a1x plus a0, where this n is a whole number and ai's are real number with an not equal to 0 is called a polynomial function. It's called a polynomial function. So any such function whose expression is a polynomial in x is called a polynomial function. And already you know this is called the degree of the function. N is called the degree of the function. Obviously, degree of the polynomial is known as the degree of the function. So this is a very important point. For polynomial function, we have to note two very important things. One thing, polynomial functions domain is the complete real number always. Then range of a polynomial function of odd degree, remember it, not even. Odd degree is always again the real number, that is minus infinity to infinity. These things we have to always remember, keep in mind. Now we'll see number two. Number two is algebraic function, right? Algebraic function. Now what is algebraic function? That is very important. A function y equal to fx is called an algebraic function. Algebraic function if we can express, sorry, I am trying to just simplify the sentence. I could have written a very mathematical statement that I will not write. We can express y minus, or if it this as an f of, sorry, just y to the power n, an minus 1 y to the power n minus 1 like this. What exactly are these quantities? I'll tell you. This is a2 y square, a1 y to the power 1 and a0, where an minus 1 right? These are integers, remember it, right? And y is the function x, function fx. That means, that is, if we can find, this is equal to 0, this is equal to 0, we can find a polynomial in y which is satisfied by y, that is y equal to fx. Just you. So here, what I can write, any complicated functions that can be written as a polynomial. Case, let me try to tell you. If you write x square plus x plus 1, see, I'm taking here simple function also. This is a algebraic function. Why? Because you multiply this, and every time you multiply this, you can express, right, this as a polynomial in y, right? Polynomial in y, right? So right at this moment, of course, I haven't written in that form. Actually, your form should have been, right? That is, this I'll not write. Instead of that, I'm writing another equation. You could write like this. Suppose one function is there where it is, say y should come here. Remember it. Y should come here, and y equal to some, say, x square plus x plus 1, and here you write cube. Suppose this is 1, and then you are writing power, say square, may not be continuous power, it is not necessary, this equal to. So that means this particular y, that means this y equal to fx is satisfying this polynomial. So in that case, this y equal to x square plus this is called a polynomial function, right? Here, sorry, algebraic function. I have considered a polynomial. Instead of that, you can consider this as a whole in place of this, right? It may be like, okay, you are considering only powers. You may be saying some polynomial, so you are considering. It may be like this also. Say root over x plus 1 divided by x. So इसी का एक अगर polynomial बना लेते हो, जैसे मान लो this, this is the y, you remember it, this is y. Say it is like this, y के value में यहाँ पे लगूँ. So if you are getting anything like this is called an algebraic function, right? Where y is this word and y is satisfying this polynomial. Because in place of y, if I put it, it is making it 0. So that is the idea of a polynomial function, right? So now I'll go to the next part. Now, number 3. Transcendental. This is the transcendental function. Now, any function which is not an algebraic function, any function which is not an algebraic function is called a transcendental function. Now, what is transcendental function? We'll give you examples. For example, a logarithmic function you can consider y equal to fx, or exponential function you can consider. Right? These are example of transcendental functions. These are all coming in the category of transcendental functions, etc. Right, so we'll be studying this also. So this type of functions are said to be transcendental functions. Next one more type you can get here is rational function. Actually, rational function will be there in the category of algebraic function only. What I write, any function of the form, any function of the form fx equal to zx by hx, where zx and hx are polynomials, right, is called a rational function. Now, you should remember that here denominator should not be equal to 0. That also you have to take care. So I think that is worthless to mention because it is automatically understood. So any such thing, actually when I wrote one function here, that was a rational function. When I wrote, that was also algebraic function. If I write it like this is a rational function. Right? Somebody might write like x plus 1 by x is a rational function, etc. Right? So please note it down. So here is the next word. Now, some standard functions we will discuss. Some standard functions. This we should know and we should be able to remember its domain, range, everything every time we do the other problems. Right? So this is a very important point to remember. The first thing we would study is identity function. Identity function. Identity function क्या है? A real function f from R to R which sends the same element to the range is called the identity function. Identity function, right? That is, what does it mean? That is, if f of x equal to x for all x belongs to the domain. That means when you give the input as x, output is also x. That means it sends the same element in the range. So this is known as identity function, right? So for a moment, if I just try to see a small graph, and graph means I'm talking about the arrow diagram. So identity function is represented like this. Just for the understanding, I'm doing it. That is the function. Identity function is more precisely defined as I from R to R. Whatever input is there, it will relate here itself. Right? So if you put 1 here, 1 will be sent here. If you write say -2 here, it will be sent to -2 here. If I write half here, it will be related to -1, right? So from here it is very clear. From here it is very clear, right? That whatever is the input is the real number. That means domain is real number, and whatever is the input, that itself is coming as the output. So range is also real number. In fact, codomain is also the real number. So these three things you have to remember. Now we'll be trying to draw the graph of it. A rough graph we need to know, right? So that must be known to us. It is graph graph of this. Okay, very nice. So for drawing the graph, we need a table, right? We need a table. We'll be drawing a small table. Actually, without drawing this table also, we should be able to do. Next function onwards, we'll be doing with the table only. But just to start with, I'm drawing a table here. And then you see how we insert the element. This is just for understanding and make little formal about this. So we are going to find the points to write some of the elements, right? For example, this will be the place for x, this will be the place for y. Y means what? It is fx. So here if we give the input 0, output is coming 0, right? Same, if I give 1, 1 will be coming, 2, 2 will be coming, minus 1, minus 1, minus 2, minus 2, right? Say minus 5, minus 5. So no matter whatever input you give, that comes out as the output. So now let us just try to draw the graph of this function. Okay? It's a rough graph we need to construct. So this is the axis, x-axis and y-axis. Of course, we will name it formally. This is x dash, x, y, y dash, right? This is the origin. Now divisions I do not want to make here. Let me not make any divisions. Directly a rough one I'll consider and I'll tell you. See, suppose 1 is up to here. This much is the division I do. The rest I'll just, the idea will go for. First element is 0, 0, first point. So it will be marked here. Then is 1, 1. This side 1, this side also 1. Very nice. Then 2, 2. 2 is up to here and then 2 will be coming here. Very nice. Then minus 1 and it will be minus 1. Then minus 2, minus 2. Minus 5, minus 5 like this. So now if you observe and join these with the lines, if you try to draw a line joining these points, then you will find that this is a line passing through the origin, right? Passing through the origin. But these points are not very well located. Anyway, that's not the issue. So you can understand this. So this is the graph of the identity function y equal to fx equal to x, right? Here, what is the peculiarity you need to note? This angle is 45 degree. This angle is 45 degree. And it goes to the first quadrant and the third quadrant. Always you try to remember this, right? It's an easy one. So now I'll go for the next type. Number 2. Second. That was identity function. Right. Now we'll go for a very important one. That is modulus function. Or we can call it absolute value function. Absolute value function. Right. So now what is absolute value function? Just wait. Let y okay equal to fx be a function from real number to real number. I could have written in the symbol also, such that it sends the absolute value to the range, right, to the range for every entry is called the modulus function. Is called the modulus function. Now I'll be defining you formally also, means mathematically. That is what it does. Y equal to fx. This is equal to modulus of x for every x belongs to the domain. Domain is what? Real number. Right? Now outside I'll explain you what does this mean. This means it is the absolute value of x. Absolute value matlab magnitude, right? Rather, I say magnitude of x. Magnitude of x. What magnitude of x means? That means the value, the numerical value associated with it. That is, if I talk about modulus of 3, it means 3. If I talk about modulus of minus 3, still it means 3. That means I'm not bothering here about the direction. This is the modulus function, right? Be very, very clear about this. Always we have confusion left for this. So here I would like to rather separately define this. That mod of x is x. That means whatever entry or input you give, that will be the output if your input is a positive quantity. And if you give zero input, output will be also zero. And if you give a negative input, so obviously you cannot write this as x. It should be written as negative x. Why? Because already this x is negative. So putting one negative sign in front will make it positive. So minus x is the output when your input is a negative, right? In this case, we can see the negative here, so we drop this. But the process actually is what? As minus 3 is negative, the value should be negative of negative 3. That means it should be positive 3. But as it is numbers and we can see the minus, we have a scope to drop the minus sign immediately and we can easily write the magnitude. So that is the idea of your modulus function, right? Please say this. So now, what I explained from here only, you can identify here that if x is input, right, it is output, right, and this output is always positive or else zero, right? That means why I'm writing this, because see, your input is, you can write if x is real input, we have to give real input here. So domain is clearly the set of real number. And if you talk about the range set, here you will be getting it from 0 to infinity, 0 to infinity. And of course, codomain is a real number. It is worthless to write, but still. So here, because of saying this, I have explained these things. Now we'll be trying to draw the graph. This time I will not draw any such table what I did this time, right? Because without that also now you can understand. So here we are going to draw the graph of it. This graph is very, very important. Really, very, very important. Please try to this and I'll discuss something related to this also. So suppose, okay, I'll not write the same x, y, z that you try to understand. Zero, if you give the input, output will be zero only. Fine. If suppose one you are getting as the input, what will be the modulus of one? One. Right? Then if you take input as two, output will be also two. Input as 3, output will be 3. I'm considering only the integral values. This will give the idea. Then if I consider minus 1, you will not get this time minus 1. You'll be getting plus 1. That means upper side of y-axis. If you take minus 2, you will get like this. Minus 3, then you'll be getting like this. So this time, if you have observed it carefully, your function will be like this. Graph will be like this if you join. Right? Once you join this, once you join the points, your graph will be looking like this V. It is a V type of graph. And then this particular angle is 45. This particular angle is 45. And obviously in that case, this will be 90 degrees. That means modulus function has a graph whose shape is like a V and the arms are making angle 45 degrees with respective positive and negative x-axis. And arms are inclined at an angle 90 degree. So this is the idea of a graph of modulus function, right? So please just be very, very clear. And in this particular point, which is a tip of the V, it is called the vertex of the modulus function, right? Vertex of the modulus function. How did you obtain the vertex? Whenever the modulus function is this, so you simply equate this quantity to 0. That will give the vertex, right? So in case, suppose you want to draw the graph of this, I'll discuss it elaborately. Just now talking about the vertex, then this function will be having a vertex at point 1 where x is 1. That means 1, 0 will be the vertex, right? So please note it down. The rest I'll define clearly. So I'm going to the next word now. So now next, number 3. Number 3. So here we'll study very important functions. We have a lot of functions to study. Now we'll study uh, greatest integer function. Greatest integer function, which we call GIF in short, or there is another name for it. It is floor function, or we can say integral part function, right? Integral part function. So we have a very varieties of options for each name. So normally we call it greatest integer function. What it is, just let me write the definition. Okay. A function f from R to R is called to be the greatest integer function if y equal to fx is equal to this box. This box means what? It is the greatest integer not exceeding x, or in a particular moment we can write that it is integral part of x, integral part of x. So this much we can write, this much we can write, right? So I'll be explaining you what exactly is this box saying. So that must be understood, right? So just for explanation, okay, let's see how we'll go for the quick explanation of it. Suppose someone is saying that you need to write what is the greatest integral value of 3.5. So what you have to write, see, what is the statement? Greatest integer not exceeding x. Not exceeding x means it might be equal to x also. And it is integer. So just identify all the integers which are less than, because not exceeding they have said, less than 3.5, which is decimal. So what are the integers? All the negative integers will start, right, 0, 1, and will go up to 3. Because after that, after 3, there is 3.5, and then 4 will come. So 4 will not be coming in the category. So out of that, which one is the greatest? 3 is the greatest. So this value will be 3, right? So you can easily see that this is the integral part of the number. Similarly, if tomorrow somebody will say that it is 10.9, what is the value? Yes, it is 10, because it is lying between 10 and it is lying between 10 and, so this way we can find the value of the greatest integral functions. Similarly, if somebody asks you, suppose someone is asking you, write 3.4, what is 3.4 equals? Suppose 3.4 you write, what is 3.4 equals? 3.4 will be equal to 3. 5.9, if somebody asks what it will be, right? Acha. Even it is 0.001, what you write 0, because see, idea is very, very clear. Idea is very clear that when you draw the number line, right, and then you are finding, suppose this is 1 and this is 2. Any integer if you find in between 1 and 2, say zero point 0.5. So immediately whatever is, sorry, 0.5 me 1.5. It is between 1 and 2. So immediately you can see the left. You stand over this point and see the left. Whatever is the first integer, that is your value. Whatever is the first integer, that is your value. So in that way we got this, and that indirectly imply that it is the integral part. Acha. What if you stand at 2? Yes, if you stand at 2, you see first integer to be 1. But try to also see here the definition. It is told not exceeding x. They are not saying that it cannot be equal to the number itself. It can be if it is integer. So if you are already standing on the integer, then value will be returned as integer only. But if you are not standing in integer, decimal number you are standing, then you should return the value as the integral. This is one of the part we should see. Okay. Now you should come to the other part, which is again very important. Okay. What if I call greatest integer function for minus 3.5? Will it be, now you have to imagine, where will this particular point lie? Minus 3.5. So minus 3 will be here, minus 4 will be here, somewhere exactly in between minus 3 and 5. So what is the left one? Minus 4. Right. So similarly, if someone is suppose telling you that 10.9 value will be minus 11. Now, does it not satisfy this particular statement, integral part of x? Because I told you that this is integral part of x. Acha. How is it satisfying them? Because integral part is minus 3 here, minus 10 here, but you are writing 4, minus 4 and minus 11. Not exactly. Just you try to remember, there is a very important thing to know. When we talk about decimal part, always it should be positive or 0. So whenever you are talking about the number 5, 3.5, actually you are talking about minus 3, minus 0.5. So you will not tell this as integral part until and unless this part is made positive. So this can be made positive by doing a small plus and minus thing. So this will make minus 4 and then this will be plus 5. And when you make this particular decimal part positive number or 0, then you have now right to say this is the integral. So for minus 3.5, it is the integral part. But for better understanding, you can say like this only. If it is not integer, stand at the point and see the left. The first integer you meet is the required value of the greatest integer. Right? So this is what the greatest integer function tells us, and we have to remember this everything, right? So now before I go for the graph, I'll go for the graph also now. But before I go for the graph, let me try to write about the domain in range that you can write now. First of all, there is no restriction in the input. That means domain will be the real number. There is no restriction at all. Domain is complete real number. There is no problem, absolutely. Any real number you can give as input and you can get the result. Achha. Output is what? Now you can easily justify only range of f output. No matter whatever number you give as input, in return, what you are going to get? All integers you are going to get. So the set of integers is going to create the range, right? And about the codomain, there is no restriction. Codomain you can say to be real number. So these are the things which you have to remember in regards of greatest integer function. Now we see. We'll be talking about the graph of modulus function. Graph of, sorry, again I'm saying modulus, not modulus. Modulus, so it did graph of greatest integer function. GIF. Graph of greatest integer function. Okay. So for doing that, first let me try to see how we could treat the domain. We have to first treat the domain in various forms. If you do not treat the domain here, then you will be in problem, because we have seen here varieties of changes. So let me divide the domain into unit intervals. Unit intervals का मतलब है intervals of length 1 unit. So we have divided it. Now just try to see. I'm just trying to make it little diagrammatic so that you will understand it. At point 0, greatest integer function value is 0. At point 1, greatest integer value is 1. At point 2, greatest integer value is 2. Right now you can easily see that all integral point integers will be returned as it is. Whatever is the input, they will be returned as it is, right, by the function, by the machine. The problem starts when you talk about the intermediate points, right? When you talk about the intermediate points, then only problem starts. What problem starts? Bigger problem doesn't start. Remember it. It is still a small problem. If I talk about any point here, see, by shading region, I am saying I am not reaching up to 1. So कोई भी ऐसा number, whatever is coming between this, what it returns? 0. Because if you stand anywhere here except 1, you will see the first number, first integer in the left side as 0 only. So that means, see, I'm just going to write something here. If you pick this x from, see, 0 is also included, because if you stand on 0, then also you will see 0 or any point here. So 0 to 1. 1 is not included, because at point 1, if you stand, you will see 1 only. So value of the greatest integer function is 1, right? Sorry, I'm sorry, 0. Similarly, at this point, if you stand in between 1 and 2, whom you are going to see? You are going to meet 1, right? So I do hope that you have understood this. So if I pick x from 1 to 2, your greatest integral value is 1. Similar trend now can be easily obtained. I should not, I think, explain more. You will understand very, very easily. So now you can continue this process forever. In fact, forever I am saying because real number has infinite number. Okay. Now I did not write at all anything for negative. Let me try to think about negative also. Supposing that you are standing somewhere in between -1 and 0, whom you will see in your left, -1, right? So for minus intervals also, supposing that you pick from -1 to 0, you are going to return every time with -1. Then if you pick x from -2 to -1, you are going to return, you are going to be returned with -2, right? Can you see this? This is the main part which you should do before you draw the. Of course, if you do not do, then also you will be able to understand. But as we are doing for the first time, I'm taking this option to explain it. So these are the things what we have arrived at. So accordingly, you have to now draw the graph. Acha. Then again, I'm saying that there is a name called uh, floor function. Why is that name given to it? Right. So there is a very clear cut reason here. Every time you see, when you take the interval, you are choosing the value to be the smaller one. You have seen the smaller value is being chosen. Right. Here it is 2. Right. Here it is 1. Here it is 3. Every time, whatever intervals you are taking, the smaller side means ground side, that is the floor. So that is the reason why GIF is also known as floor function, right? So now we are about to draw the graph of it. So we are going to draw the graph of it. This graph will be little, I should not say critical, but it is technical. So you should be able to understand it. You will understand definitely, I'm sure. So how we draw? You have to draw every interval here, because here your inputs are dependent on the interval, right? So your main divisions of x-axis are this, and in fact, y-axis are also to be divided in that integers only, because this time very clearly your returns are always the integers. You are not going to get any decimal as return, right? Very nice. Now just try to see. If you give input 0, you'll be here. If you give input anything which is from 0 to 1, your output is always 0. That means y value will be 0, meaning points will all lie on y-axis. But moment you step into 1, you will directly jump up to 1, because at 1 you have to look at 1 only. मीनिंग क्या है इसका? व्हाट डज इट मीन? यही समझना है. मीनिंग बहुत क्लियर है कि तुम 1 तक नहीं रीच कर सकते हो बिफोर, जस्ट बिफोर 1. यहाँ तो हमने बहुत बड़ा गोला बना दिया, इतना गोला बनाना ही नहीं चाहिए था, छोटा गोला होना चाहिए. एक एम्प्टी गोला बनाएंगे. एम्प्टी गोला का मतलब है यू कैन नॉट रीच अप टू दैट पॉइंट व्हिच इज एनक्लोज्ड, एंड थिक गोला का मतलब है यू कैन कम ओवर हियर. एंड दिस आई एम ड्राइंग, राइट, ऐसे करके ड्रॉ कर रहा हूं. इसका मतलब है कि तुम इस वाले लाइन में चल सकते हो द इंटरवल 0 to 1, राइट. सो तुम्हें ऐसे मिल गया. इन द वेरी सिमिलर नोट, इन द वेरी सिमिलर नोट, अगर मैं चला जाता हूं इस वाले इंटरवल में, तो 1 से शुरू करके अप टू 2 तक जा सकता हूं. 2 को नहीं लूंगा, तो फिर मुझे 1 में चलना पड़ेगा, राइट. तो आई विल बी मूविंग पैरेलल टू एक्स एक्सिस a distance up to 2, right? So here also you should be very clear that there should be an open gola, and here it is a closed one. What does it mean? That means you can stay here, but you cannot reach up to this. In this particular way, if you go to the next, then from here you will start and you will go up to 3. But remember, you are unable to reach 3. So here it is open and here it is closed, right? So to make it little more attractive, just I am changing the color. So next will be from here at the level 3, right? So you will be finding here a open gola, and this is your thick one. That means it will indicate that you can come up to that point, right? So then I can get the another line here, but I cannot reach -1. That must be remembered. I should not forget this. But -1 at x-axis I can reach, but not y-axis, right? Because moment I consider -1 as x, I'll fall here. I'll fall here. You can see whenever it is -1. Sorry. I'm sorry. I think I told you x equal to -1. Sorry, x equal to -1 will give you -1, but x equal to 0. At this point, x equal to 0. So you will fall directly at this point. So you will not touch -1 in the y-axis. So likewise, if you complete the graph, you will find a very nice structure, which is a very beautiful function, really beautiful function. So here it is open and here it is closed. So now look at the structure of the whole thing. Look at the structure and you will find that this is a fine staircase going up, right? Fine staircase going up. This is also known as step function, one of the step function, right? It is not only step function, there are many step functions. This is one of the step function, right? And to be more precise, you can write step up function, right? So this is what the graph of your latest integer function is. Very clear. And you see when you draw the graph in the plain paper, so you can draw a line like this also, in order to keep a track of the points so that you will not commit mistake here. Like this lines, I did not draw it. I don't know to what extent it is accurately seen by you. So like this, you can draw this so that your accuracy level will be more, right? So this is the graph of the See, I'm not very accurate here because it is not passing through all the points. Of course, this is very true. Okay, so please go through it and let me know. So let me go to the next page to take the next function, that is number 4. Okay, this is a common question. If floor function is there, obviously there might be something called ceiling function. It is there. So that is called least integer function. Least integer function, और प्यार से हम लोग बोलते हैं इसको ceiling function. SEILING, ceiling function. Now it is very clear. Earlier, whatever concept I have explained you for greatest integer function, इस बार तुम्हें दिक्कत नहीं होगा क्योंकि पिछले बार जब फ्लोर मतलब नीचे वाला पॉइंट लिया था, इस बार सीलिंग मतलब ऊपर वाला पॉइंट लेंगे, ये ऑटोमेटिकली आएगा और इसको लीस्ट इंटीजर फंक्शन ऐसे बोल सकते हैं, right? LIM. So now, first let me write a definition and then we'll be talking about this. A function f from a real number to real number such that y equal to fx is equal to, see the symbol, we call it like this. It is similar almost to the previous one. It was a closed bracket in the previous one, but here you see the bottom points, they are not enclosed. This is called the lowest integer function. Integer function or integer value function. Wait, now you might be expecting, what does this mean? This is the, earlier it was the greatest integer. This time we'll write this as the smallest integer. Not, it was not exceeding previously. It is not less than x. Just the reverse of the previous one. So it is what, this time if I need to explain you, you should stand at that particular point and see the right. Whichever is the right, first right integer you get, that is the value to be returned, right? So I'll just pick 2-3 examples. Now it will be very, very clear to you. There will be no doubt at all. I'm sure about that. So supposing that 3.5, I want to find the lowest integer function. So this time it will be what? -3. Because once you stand at -3.5, right side, first integer you will meet is -3. So if I talk about 2.3 rather, then you will meet 3. Here also one thing is very common to them. If the place where you are sending is integer, then you should return the same value, right? So that is the thing you have to remember. And then again, for drawing the graph, I'll draw that line of division of interval. This time I think if I do not explain you so elaborately, then also it will do, because already you got a good experience about the previous ones. So this time I'll just directly write the values so you can easily grab things, right? So this time you see at 0 you will return 0 only, at 1 you are going to return 1, and moreover at all the points between 0 and 1 you are going to return 1. So category has been divided like this कि 0 को include नहीं करना है, इस बार 1 को include करोगे. तो इससे क्या आइडिया मिलता है हमको? I'll be just categorizing it. X belongs to 0 to 1. That will imply the value of this function is 1. X belongs to 1 to 2. That will imply the value of this function as 2. X belongs to 2 to 3. Sum of this, I'll write it so that you can get it easily. This is giving you 3. In the very similar note, if you talk about minus values also, say -1 to 0, then you are going to return this value as 0, etc. So now these things will take the help for drawing the graph of it, right? So please see this, and once you finish it, let me know. So for a graph, we'll switch onto the new board. See. Okay. So Here we will draw the axis. This is the axis here. थोड़ा टेढ़ा हो गया, कोई बात नहीं, चलो चल जाएगा समझने से मतलब. Okay, so now we are going to look at the points. पहला पॉइंट यहाँ पे होगा, ये 1, ये 2, ये 3 थोड़ा इक्वल करने का कोशिश कर रहे हैं हम लोग. I'm trying to make it little more better. This is 1, this is 2, -1, -2. Okay, up to -2. Fine. So now just try to take the advantage. क्या होगा जब तुम जीरो को रखोगे, जीरो के पास जीरो मिलेगा. वेरी फाइन. और अगर तुम इंटरवल देख चुके हो तो तुम्हें पता चलेगा जीरो इस वाले में आएगा, क्योंकि यहाँ कहीं भी खड़ा रहोगे राइट साइड में जीरो दिखेगा. तो दिस टाइम वेरी वेरी क्लियरली यू विल omit 1. You will omit 1, -1, and then you will draw a line. Sorry, थोड़ा सा अच्छा दिखे ये. You will draw a line here, right? So that is the graph. So this time you can easily identify that the point 1 has been -1 has been removed, 0 has been considered, which is just the opposite what you did in the previous one. Similarly, from 0 to 1, 0 will not be included now, but 1 will be included. And in this range, you have to look up to 1, right? So this line will not start from 1, right? But you will go up to -1. You are allowed to go up to, sorry, +1. And then this will be an open circle. Similarly, now I think you got the trap. I should not now explain more about this. You can easily identify 2 will not be this, -1, sorry, 1 will not be included, but 2 will be included in x-axis. So this point will be a dark circle, whereas this will be an open circle. So in this way, similarly, you could complete the whole graph, right? So here also, I'll draw this. I can move up to this point and then be very precise. This point is allowed to be included. This is not allowed. So here also you will find a very, very beautiful graph. This is also step function. Please be assured about that. This is also one of the step function. स्टेप फंक्शन का बेसिक आइडिया है कि स्टेप जैसा दिखता है. दैट्स द ओनली थिंग. इसमें और कोई दूसरा सीक्रेट नहीं छुपा हुआ है. इट इज लुकिंग लाइक ए स्टेप, सो वी कॉल इट स्टेप फंक्शन, राइट? बट यहाँ पे मैंने डोमेन एंड रेंज नहीं लिखा, तो यहाँ लिख देता हूँ, मैं भूल गया था. तो डोमेन इसमें क्या होगा? व्हाट विल बी द डोमेन? डोमेन इज अगेन एवरी एंट्री व्हिच आर रियल नंबर. देयर इज नो प्रॉब्लम. रेंज में क्या मिलेगा तुम खुद ही देख सकते हो. रेंज में तुम जो भी डोमेन में जो भी तुम एंट्री करते हो, रेंज में तुम्हें मिलता है बस इंटीजर. सो इट इज z. एंड कोडोमेन इज व्हाट? इट इज अगेन द रियल नंबर्स. So this is all about the lowest integer function. Just you see, next function we will discuss in the next period. Now just I'll give you a idea to draw a modified modulus function. To draw, suppose we had understood how to draw mod of x, right? Now suppose somebody asks you to draw what is mod of x minus 1. How you are going to draw, you see, how you are going to draw. I'm just explaining you quickly, right? The background you will understand yourself. I will not explain you today. So for drawing this, just you see where the vertex will lie. Where will the vertex lie? At x equal to 1. So you mark it here, right? And the v what you constructed at 0 earlier, this time you have to construct a v here. That's the quick thing. That's the quick thing. So you need not bother anything about it. You have to remember these things, that this should be at 90-degree angle, right? So it is very, very easy for drawing such a modulus function when you modify it, right? So similarly, if tomorrow someone will say that I need the graph, modulus functions graph of x plus 3. So what you will do? Nothing. You will just draw the axis very quickly and you will find where this value becomes 0. It is becoming 0 at what? X equal to minus 3. So suppose this is minus 3. At that point you have to raise that fee. That's all. So your modulus function will be ready here like this. This is the ready function, right? So this is what we can draw. Acha. Now if in case somebody will tell you that I want to find the modulus function y equal to say 3x plus 2, how will you do? How will you do this? So 3x plus 2, where it becomes 0? Where it becomes 0? It will become 0 at x equal to minus 2 by 3. But there is something we have to see. What is that something? Let me try to explain you. If you take a 3 common, then it will be x plus 2 by 3. So this is talking about a vertex. See the technicality of this particular graph, right? देख लेना इसको ध्यान से समझना. अगर मेरे पास ध्यान से देखना, ठीक है, अगर मेरे पास बस ये हिस्सा होता तो इसका वर्टेक्स तो -2/3 में होता and then I would have easily reached a V making 45-degree angle with both the axes. ये मेरा होता, right? ये मेरा जरूर फंक्शन होता. लेकिन कहानी को देखो इस बार, ये मगर 3 से मल्टीप्लाई हो रहा है तो ये वाला वैल्यू का फंक्शन जो मिलेगा उसको 3 से मल्टीप्लाई करना है. 3 से मल्टीप्लाई करना है. यू हैव टू मल्टीप्लाई दिस बाय 3 टाइम्स बढ़ेगा. इसका मतलब क्या हुआ? जब इसका मॉडुलस फंक्शन बना होगा, जीरो तो यहाँ पे ही रहेगा, बट द वैल्यू दिस विल गो stiff, more stiff. Careful about it. Because every time you give any entry, that will be 3 times then this value. Did you understand?